Hi, we're the Ocean Going Robots ECE Senior Design Team. Our team consists of Malachi Fisher, Grayson Lewis, Miles Drake, and Samuel Barton. Our project is to develop a system to measure wave swell amplitude, direction, and period for the Slocum G3 glider as it floats on the surface of the ocean while consuming a minimal amount of battery power. Our goals that we accomplished from the previous week: we finished our project document, section 3. We finalized our block assignments. We implemented feedback for our project document, sections 1 and 2. And we notified our project partners of any changes to those project documents. We completed the block diagram and interface definition draft, and we successfully interfaced the XSense sensor with the STM32 board. Additionally, we had a pleasant Thanksgiving.
So one of our goals for this week was to have successfully interfaced with the XSense IMU. So to do that, I wrote firmware to sample orientation data from the XSense. I took some of the libraries that XSense, the company, provided for encoding and decoding their XBus messaging protocol. And I took those libraries and I modified them to work with this particular Nucleo board, and was able to use those to send and receive, and importantly, interpret the messages coming out of the IMU. And then once we had that working, I used a web-based visualization tool to show that the sensor is working correctly and that we're getting good data from it. And we're going to show a video of that now. So as you can see, we were able to get valid data, in this case, our orientation in quaternions, and we're able to get that from the sensor and then send it out to the computer to show that it's working.
We finalized our block assignments this week. I will be heading up the SD card interface firmware, as well as the micro SD card and board itself, and interfacing that with the main board. Grayson will be heading up the serial interface firmware, the accelerometer block, as well as the XSense control firmware. Sam will be heading up the microcontroller block, as well as the data analysis firmware block and the mainboard PCB block. And Miles will be heading up the buck regulator block, as well as the power management block and the main firmware block.
On top of the work that we did with the IMU this week, we also attended a review on Fourier transforms with our project partner. This was mainly a math review of how to turn accelerometer data into a wave spectrum that'll be passed through a wireless link back to shore. We did an overview of the Welch method, which takes different parses of the data and moves them in a specific area to give an FFT on separate chunks, and it'll make it easier for our data, which will be small amounts, to get something accurate. We did this with our project partner, Pat Welch. We'll be creating our own FFT to be used on the microcontroller, which will be mainly focused on acceleration data and possibly orientation, which will be sent back to shore while the glider is deployed, while the CS team will be working on a more in-depth FFT and other data analysis algorithms to get something better for onshore purposes. The work that we did on the project document, as we stated earlier, was we finished the initial draft of section 3, including the block diagrams, block descriptions, and interface definitions. We are also implementing the instructor and peer feedback we received on sections 1, 2, and 3. The main feedback that we got from our project document from both our peers and the instructors were that our requirements in section 2 were somewhat light, and we needed to make them denser to fit a 1/8 workload of what our project entails.
We met with the course instructor, Donald, here last week, and his main issue with our project so far was that the scope of it wasn't great enough for a 4-person team. So his suggestion for that was that we do some of the CS teams work as overlap. And so we'll be doing some FFT and data visualization code as well as them. We also, during the meeting, went over some other requirements. We removed some requirements that were not system level, including the SD data transfer speed. We're looking to make every requirement we have as system level as possible. And our goals for winter break: we want to complete the STM32 to SD card interface. We want to design and order the SD card PCB. And we'd like to meet at least once to discuss our plans for the coming term. Additionally, we'd like to take some time to relax and recharge.